On our data sheet, we now have 6 equations that we're allowed to use in different situations. The first one, v equals delta d over delta t, and then the other 5. Vf squared is equal to vi squared plus 2ad. We got a is equal to delta v over delta t. We have d is equal to vi plus vf over 2 times t. We've got vit plus 1 half at squared. And finally, we've got vft minus 1 half at squared. Now, they don't necessarily appear on your data sheet in exactly this order. I can't remember the order that they appear. It doesn't matter. Okay, the basic layout of our data sheet is the same. This first equation, v equals d over t, we circle that, and we put a little a beside it. We call that our group A equation. We apply that group A equation whenever we have a constant or average velocity, and that's it. No other time. Constant velocity, average velocity, that's it. We circle the other 5 together, and we put a little b beside it. These are our group B equations. They're all valid in the same situation. Just depends upon what givens we have. That situation is one in which we have an acceleration. So read your question. Don't even worry about your givens. Read your question. Identify whether you have a constant velocity, an average velocity, or the object is accelerating, speeding up or slowing down. And then identify which group of equations applies based on that. Then write down your givens and determine which one of the equations from the proper group seems to fit the best. All right, let's say it's a group B problem, because that's what we're doing right now, right, is those group B problems, those acceleration problems. Let's say you're doing one of those, you get your givens written down, and you're just not sure. Is it this one, or is it this one? Is it this one, or is it this one? You're just not sure which equation to do. As long as you're within the right group of equations, it doesn't matter. Try one. Try one. The worst that's going to happen, as long as you're within the right group of equations, is that you're going to have too many unknowns, not going to be able to solve for anything, or you're going to solve for something you weren't looking for. I promise you, you don't get the wrong answer. If you use a proper equation, even if it doesn't get you the answer, it's not going to get you the wrong answer. So don't sweat it. You're not sure which one to use? As long as you're in that group of equations, A or B, just pick one. Guess. Guess if you have to. If it gets you what you're looking for, great. If it doesn't, then guess again. Here's the deal. There's only 5 equations in group B. If you guess once, it doesn't work, and you guess again and it doesn't work, there's only so many times you can guess before eventually you have to get the right one. And that's okay. Okay, there's no shame in that. All right, we had 2 questions for homework last night using group A and or group B equations. They were page 48. Any issues with either of those questions on page 48? They're both good? No troubles? All right. Well, let's do another example then. Same stuff, nothing new. Relates back to that page I just wrote down with the 6 equations that we've learned, our group A and our group B equations. This one says a golf ball that's initially traveling at 25 meters per second. It's a sand trap and slows down with an acceleration of negative 20 meters per second squared. What's its displacement after 2 seconds? So it's taking 2 seconds for this sand trap to stop this golf ball. The golf ball, as it slows down, is slowing down at a rate of negative 20 meters per second squared. We want to find out how far it travels during that time. In other words, how far into the sand is it actually going? Now, ask yourself one really important question here. Is this a group A or is this a group B problem? Group A or group B? It's B. It's accelerating. It's actually decelerating, right? But that's just a negative acceleration. It's slowing down. So let's put a little note there to remind me that it's a group B equation. Let's write down some givens, and then let's look at my list of group B equations and see which one happens to fit the best, if I can identify that. If I can't, then that's okay. I'll guess, as long as I guess from the right category. All right, what do we got here? 25 meters per second. I got negative 20 meters per second squared. I've got 2.0. What's the first one? What's the 25 meters per second correspond to? Yep. Good. It's VI, initial velocity. Now, we don't really know what direction that's going, but we'll say it's the positive direction, and we'll call it a velocity as opposed to a speed. Now, if I need to use an equation with speed in it as opposed to velocity, that's okay. We'll just make it speed because nothing's changing direction, so speed and velocity will have the same value here. Not a big deal. What's the negative 20? What's the negative 20? Yeah, Sam? Good. It's a deceleration. We're going to call it A for acceleration. It's the negative that tells us it's a deceleration. What's the 2 seconds? Here's the easy one, right? The 2 seconds. Huh? 2 seconds. Right. Is there anything else that we have here if we read between the lines? We're looking for displacement, right? Yeah, I'm going to write that one down. I'm going to take that one away from you, the easy one. Is there anything else that we have if we read between the lines here? Hilda? Good. What is it? Good. We want to know its displacement. Oh, wait a second. Wait a second. Wait a second. No, it doesn't actually say it comes to a stop, does it? That's okay, because I made the same mistake as you made. We don't know that the final velocity is 0. If it says the sand trap stops it, or if it says it comes to a stop in 2 seconds, then we could say VF is equal to 0. And they may mean that. I'm not sure. But they don't say it. So we're not going to write that down as VF is equal to 0. I kind of tricked you there because I was thinking that was VF myself. So I was kind of leading you into saying that. But that's not the case. At least we can't assume that it's the case. All right, we got D, VI, T, and A. Let's go back to our equations here. We said it's a group B problem. We got D, we get VI. No, we're looking for D. We got VI, we have A, and we have T. Which one do you want to try here? Yep, Nathan? This one? Okay. Is that what you were going to say too? Okay, so let's try that one. Looks like it seems to fit our givens here. But you know what? Worst case scenario, it just doesn't work for us. We try something else, right? It's a valid equation at least. VI is 25. T is 2. Be careful right here. A is neg 20. If you make that a positive 20, then you're going to get the wrong answer. And if this happened to be a multiple choice question, which it probably wouldn't in physics 20, in physics 30 it would be, but it happened to be a multiple choice question, you forget that negative in front of the 20, you're going to get a different answer than the correct answer. And that option is going to be one of your choices. That answer is going to be one of your choices. So read carefully. Make sure you identify when it is negative and positive and plug it in accordingly. All right, 25 times 2 is 50. 1/2 of neg 20 times 2 squared would be neg 40. So it's 50 minus 40, which gives us a displacement of 10 meters. Is that right? Boy, oh boy. That's a deep sand trap we got there. If this ball can embed itself in the sand trap to a depth of 10 meters. 10 meters, by the way, is about the width of this classroom. So if it can go that deep into the sand trap, good luck hitting your next shot. You know, they always say you're supposed to hit the sand, not the ball, right? When you're trying to get out of the sand trap. You're going to be hitting the sand a lot of times before you actually get the ball out of the sand trap there. Yeah, not quite realistic there, right? That's okay. I mean, it gives us the idea of using this equation and looking at which givens we have and so on. It's the process that we go through, not so much the actual question. All right? Take a look at those two questions, please. On page 50. I'll give you a few minutes to work on those. Call me over if you're having trouble. Make sure you identify things like, hey, 1 minute. We don't want minutes, kilometers per hour. Make sure you convert those to standard units of meters per second and seconds. And then let me know if you have trouble. Okay, let's take a look at question number 2, everyone. It says a motorcycle traveling at 100 kilometers per hour. I've circled kilometers per hour already just to draw attention to that. This is one of those things that You know, I read through a question. I spot the fact that it's kilometers per hour. I know I got to convert to meters per second. But by the time I'm done reading the question, by the time I'm done writing down givens, by the time I'm done looking through my list of group B equations to identify which one to use, I might forget. I might forget that I have to convert it. I know it, but I might forget it. Okay, if you're going to get a question wrong, don't let it be because you've forgotten something. Okay, you're going to make a mistake. Make it a good one at least. Don't make it some piddly little mistake like forgetting to convert kilometers per hour to meters per second. Same thing applies for this 1 minute time here. We apply the brakes, 0.80 meters per second squared for 1 minute. How far did the motorcycle travel during this time? There's one more thing in here that I want to highlight in red before I actually write down my givens and identify which group of equations it is here. Anybody kind of spot what maybe it is? Something that I should draw attention to that I might forget to do. We really got to read between the lines for this one. Luca, what is it? Yeah, it's decelerating. So this one is going to be what? That's going to be negative 0.8, right? Because it's slowing down. They don't tell me that in the question. I have to spot that. That's a really easy one to miss. Okay, if you forget to convert kilometers per hour to meters per second, I mean, there's nothing I can say about that. Remember it. But that one, that's a tough one to spot. If it's slowing down, the acceleration is a negative value. All right, it's group B, right? It's slowing down. It's a group B question. Let's identify our givens here now. 100 kilometers per hour is something. Negative, Luca told me, negative 0.80 meters per second squared is something. Something is 1.0 minutes. We're looking for the displacement here. How far does it travel? What's 100 kilometers per hour? Yep. Okay, 27.7778 meters per second. You did that by multiplying by 1,000 divided by 3,600. But what does it correspond to? Is it A? Is it V? Is it Q? No, it's not Q. Whatever that is. Julia? It's VI, yeah. Call it V1 if you want. I usually call it VI and VF, but it's not a big deal. VI is 100 kilometers per hour. Negative 0.8. Karsten, what's negative 0.8 there? Good. Acceleration. Now, some of you might say, oh, it's a deceleration. Yeah, it is, but deceleration is just an acceleration. We could still call it A. We just put a negative in front of the number, that's all. This is going to be time, right? Yelna? Do we know what VF is here? No, we don't. Just like that other practice question, right, or the example question, we're not told what VF is here. Maybe it's 0, maybe it stops, but we're not told that. So we can't write that down. Give me an equation. Yep. Oh, you're right, actually. You're right. Good thing we had that circled in red, or we might have forgotten that, right? We do have to convert the time to seconds. 1 minute is 60 seconds, right? Multiply it by 60. Give me an equation, somebody. I think I'm ready for an equation now, right? Got all the conversions done? Joseph, what equation do you want to try here? Okay. Yep. Okay, let's try it. I think that's going to work for us. I think you're right. But if you're not, then what's the worst that's going to happen? Try again. We'll either get the right answer or we'll find out that we picked the wrong equation, one of the two. VI is 27.7778 times the time of 60 seconds plus 1/2 of negative 0.80 times 60 seconds. Now we got some uglier numbers in this one. Let's do this one as a group here, just to make sure we can get this. I got 27.777, oops. 27.7778 times 60. Let's press equals here, okay? Let's do it in steps. 1666.666. Now let's say 1/2 0.5 times negative 0.8 times 60 squared. Negative 1440. So it's 1666 minus 1440. Now let's say 1666 I get 227, which that's what they got, right? They have 2.3 times 10 to the 2. It's the same thing. They just rounded it to 2 digits instead of 3 digits, that's all. Which really it should be. How many of you guys are comfortable with significant figures? How many of you guys have seen it before? Significant figures. Chemistry class. Who has no idea what I'm talking about right now? Okay. Over time, we're going to learn to round properly. Okay. There is a certain way of rounding, and we use something called significant figures to do that. Basically, what we're saying here is this. Our data, we got 3 digits here, 2 digits, because a leading 0 is 0 before our number doesn't count. Okay. 3 digits, 2 digits, 2 digits. If our least precise piece of data goes to 2 digits, then our answer can't be any more sure or certain than 2 digits. A chain is only as strong as its weakest link. Right? If you have a really weak link in a chain, the chain doesn't matter how strong the rest of them are, the chain is weak. If you have a weak piece of data that is 2 digits, then the answer could only be 2 digits as well. You can't be more certain about your answer than you are about your data. So my least precise piece of data is 2 digits. My final answer should be 2 digits. It's the first time that we've expressed that as a class. We'll talk about that in lots of the questions that we do, but I won't mark you wrong on significant digits until after your first unit test. I'll give you the entire first unit to practice that, get the hang of it, and then after that, then I'll start marking you wrong on it. Okay. If anybody's ever unsure when I'm talking about significant figures, okay, what I mean or how many it should be, just ask me, and we'll help you, okay? Try another one. Speedboat slows down at a rate of 5 meters per second squared and comes to a stop. If the process took 15 seconds, find the displacement of the boat. I got my red pen out. What do I want to circle or highlight or underline or draw attention to in this question? Not my givens, but something kind of strange that could lead me to a silly mistake here. Yeah? Good. So we're going to make that negative, right? So something is negative 5.0 meters per second squared. Something is 15 seconds. We're looking for the displacement of the boat. Sam, do you know what that negative 5 is? Good. Jared, do you know what that 15 is? 15 seconds? Time. Good. Yelma, do you know what the final velocity is? How do you know it's 0 this time? Good. So this time, it is 0 meters per second because it clearly says that it's coming to a stop. Sometimes we assume that in other questions like I did in that previous example problem, but that's not the case unless it actually says that. Okay, group A or group B? No, group B involves acceleration, deceleration, but that's a form of acceleration. Which equation out of group B, all those ones you've got circled on your data sheet with the B beside it, which equation do you want to try here? Don't be afraid to volunteer here, because if you guess wrong, I'm okay with that, as long as you don't tell me V equals D over T. Why can I not, by the way, use V equals delta D over delta T? Why am I not allowed to even try that one? Yep. It's not a constant velocity. It's slowing down. It's not a constant velocity, so I can't use that one. All right, so which one do you want to try there then? Okay, VFT minus 1/2 AT squared. VF is 0, T is 15. I'm just going to cross that off. 0 times 15 is 0, right? A is -5. Oh, be careful here. It's subtract 1/2 of -5 times 15 squared. Do the math there. Oh, what do I get? 15 squared is 225. 225 times 5 would be 1,000, 1125. Half of 1125. 562.5. Anybody have that? Negative? No, it's positive because a negative times a negative is a positive. Mathematically it works out to be positive, but logically it should be positive as well, right? You're moving in the positive direction. Your displacement has to be positive. Now, we're not losing too much sleep over significant figures at this point. Okay, that's after our first unit test that we lose sleep over that. How many should it be? 2 digits, 2 digits. My least precise piece of data is what my answer should be rounded to. My answer should be how many digits? 2. So we're going to round that. The only way to do that is to put it in scientific notation and then round it to 2 digits. It would be 5.6 times 10 to the 2 meters. If you wrote this right now, I would mark that right. Okay, in another month and a half, I won't. But right now, I'd mark that right. Okay? All right, let's try these 2 questions then. Pay attention to the kilometers per hour. Pay attention to negatives, slowing down, deceleration, right? Okay. Don't mess up on the little things. I'll give you a few minutes here and see what you can do. Have a look up here, everyone, at question number 1. It says, if the arresting device on an aircraft carrier stops the plane, the arresting device, the aircraft carrier is for the Navy, right? For airplanes taking off and landing. They don't arrest people on aircraft carriers, do they? What's the arresting device? What is that? Yeah. Yeah. You know that in an aircraft carriers are big. Like, they're big enough for airplanes to take off and land on, but they're still not that big, not nearly as big as a normal runway would be. So in an aircraft carrier, they have to accommodate for the potential of airplanes not being able to land, right? The runway is so short, if something happens that the pilot, goes a little bit too far before he touches down or she touches down, or not quite far enough, whatever the case may be, they have to have some kind of provision for that. It's not the hook. It's not the arresting device. The provision for that is the fact that the airplane, as it's coming down here, that's kind of an airplane, eh? It's a funny looking airplane, but it's the 2016 model, not yet seen publicly. Coming down to land here. Do you know what this airplane does? As it's coming down to land on this really, really short runway, relatively speaking, really, really short runway, it actually doesn't put reverse thrusters on to slow down and stop. It does exactly the opposite. They gun it. All jets forward. Why? You're trying to stop on this really, really short runway, and yet you're gunning it? You're giving it all you got here? Why? Why? Here's why. What if you miss? You're in the middle of the ocean. If you miss the airplane, if you miss the runway, or you're a little bit too far ahead on the runway, or you're not quite far enough on the runway, you miss the exact spot you got to land at, what do you got to do? Take off again. You can't stop, right? You keep going. So if you put the reverse thrusters on to slow yourself down to stop on this, you can't take off again. You're done, right? You're going to crash into the ocean. So what they do is come down here. They're coming down here. They're gunning it. They've got full thrusters forward. And then if they land a little bit too forward, they just keep going right up. And it happens all the time. So there's a problem with that, though. They're landing too fast. They're coming down. They got to land on this really, really short runway. They're going way too fast to possibly stop on here. So what do? They have this hook. They have this cable that stretches across the ship from one side of the ship to the other, this steel cable, and then they have this hook. Actually go the other way around, I guess. The hook would go this way. That hangs beneath the airplane. As this airplane comes down, assuming they land in the right spot, the hook grabs this cable, and this cable stops them almost instantly. Okay? It's a lot of G-force on the pilot, but at least the plane has stopped. Does that make sense? That's the arresting device that they're talking about. The device that keeps them from crashing into the ocean. They're going too fast. They can't possibly stop on a ship, so they have to have some help in stopping. The only reason they're going too fast is in case they miss the plane so they can take off again. Sorry, in case they miss the deck so they can take off again. All right. So it stops the plane at 150 meters. That's a pretty short distance, or a pretty short displacement. It tells us the acceleration is negative 15. That's great. Usually, they just tell us it slows down at 15 meters per second squared. This time, they tell us that the acceleration is negative 15. They're not forcing us to catch that little read between the lines negative thing. We're going to find the time that it takes the plane to stop. Oh, is that all we got? Is there anything else we have there? Yep. Good. So good. So VF is 0 meters per second. That's it, I think, now, isn't it, Bree? Okay, I think it is, yeah. Okay, it's a Group B problem, right, because it's slowing down. We can use any one of those Group B equations. Which one do you want to try first? Go ahead, Nathan. Okay, delta D is equal to VFT minus 1/2 AT squared. It's VIT plus or VFT minus. Okay, we got a problem here. T appears in two places. In order to solve for that time here, we actually have to use some mathematics that some of you haven't learned. It's called the quadratic equation. How many people have learned the quadratic equation in math class? Most of you have. Okay. You could use the quadratic equation to solve for t. Hey, you ever wondering in math class, why are we bothering to use this quadratic equation? What value could it possibly be in real life? Well, here you could use it to solve for the time that it takes this plane to stop. But in physics 20, there's never a time when we have to use the quadratic equation. I'm not going to do it here because some of you haven't learned it. If you're comfortable with it, you want to find t that way, you go right ahead. Be my guest. That's fine. But there's always another option here. Yep. Oh, yep. You're right, actually. You're right. You can avoid using the quadratic equation here because this term disappears, right? Make sense? Good call on that. If VF wasn't 0, then there would be no other option with this equation than to use the quadratic equation. There is always another option with another equation, but because some of you haven't learned the quadratic equation, we'll never force you to do that. But not with this equation. For this particular question, though, there is because VF is equal to 0. You're right. All right, so let's solve for t this way. All right, a little bit tricky here. Toughest one we've had to rearrange yet this year. Here we are, what is this, Tuesday? It's our sixth day of real stuff in Physics 20. First time we've had to rearrange an equation that's this challenging. We have to get rid of what's not attached to the t first. Well, we did. VFT disappears, so there's nothing really to get rid of here. Now we got to get rid of what is attached to the t. There's a 1/2 a in front of the t. Let's get rid of it. 1/2 a is multiplied by t. How do I take it to the other side? Divide it. The opposite of multiply is divide. So let's say d divided by negative 1/2 a. Now, you can simplify that to make it look a little bit tidier, but you don't need to. Negative 1/2 a is multiplied by t. Take it to the other side by dividing. That's going to be equal to t squared. Now, how do you get rid of the squared? Yeah, how do you get rid of that squared? Square root it. Good. So t is equal to the square root of d over negative 1/2 a. d is 150 meters over negative 1/2 times negative 15. Let's see here. 150 divided by 15 is 10. 10 divided by a half is 20. Square root of 20 is 4.5. That's what they say there. 4.5 seconds. Get that? Anybody get the right answer but do it differently? Yep. Oh, and you used this, didn't you? Okay, so VI squared would be equal to negative 2AD. Take away that square, it becomes the square root of negative 2AD. And then you said A is equal to delta V over delta T. Now that we've got VI and VF, you've got delta V, right? Rearrange it to solve for T. And there we go. And you got 4.5 seconds, right? Same thing. So two completely different ways of doing it, both valid ways, both within our group B equations. They both work. Now you can see how if this equation, if VF wasn't 0, and I did need to use the quadratic equation for here, you can see how there's another option there, right? I could have went back and done this as a two-stepper. It's kind of a trade-off in this one, right? This one's a bit shorter because it's one equation versus two, but it's harder rearranging, I think. This one's a little bit longer, but I think easier rearranging. Whatever works for you. Yeah, I want to do one more example, and then we'll just leave you with a couple of questions for homework, and that'll be it for the day. Page 52. Look at that, we're 6 days in and we're already on page 52. A bullet accelerates the length of the barrel of a gun, which is 0.750 meters, with a magnitude of 5.35 times 10 to the 5 meters per second squared. That's a pretty big acceleration right there. What speed does it leave or does it exit the barrel? Something's 0.750 meters. Something's 5.35 times 10 to the 5 meters per second squared. What's the 0.75? Jordan, what's that 0.75 correspond to? Good. Distance or displacement. Yeah. How far it's traveled in the barrel of the gun. What's the 5.35 times 10 to the 5, Tegan? No. Yep. That's how fast it accelerates. Anything else if I read between the lines here? Good. The I is 0. Doesn't tell me that, though, does it? Sometimes we just have to use our common sense here, right? Inside the barrel of a gun, how fast is the bullet moving before it begins? 0, right? It's not moving at all. So we're going to say VI is 0. And what are we looking for here? VF, right? How fast it's moving when it leaves the barrel of the gun. We're actually looking for the speed. I've got VF as in velocity there, but it's going to be the same value. Just no direction for speed. All right. All right. We're going to try. Chantal, do you have an idea to try there? Sure. Sure. It's a group B equation, right? It's a group B problem. It's a group B equation. Give it a try. Now, I'm pretty sure that's the one that's going to work out here. But if it doesn't, worst case scenario is we try again. Solving for VF. All we got to do here is square root everything. This, by the way, disappears because VI is 0. 2 times 5.35 times 10 to the 5. It's speeding up, so that's going to be a positive value. 0.750. Let's do the math here. Let's say 2 times 5.35 times 10 to the 5 times 0.75. Let's square root that. And we end up getting 895.82 meters per second. Now, how many digits should it be? What's my worst piece of data? My least precise piece of data? If 0 doesn't count, 1, 2, 3 digits, 1, 2, 3 digits. Final answer should be 3 digits, 896 meters per second. Right? If I'm not any more certain than 3 digits for these pieces of data, then I can't be any more certain than 3 digits for my answer. Hey, we started this whole acceleration thing yesterday. I think it's coming, right? I think you guys are getting it. How many people feel like they've mastered this acceleration stuff right now? Couple. Good, good. Good. But you know what? If I was in grade 11 right now and taking this stuff for the first time, I wouldn't have mastered it. So if you have mastered it, that's fantastic. You're ahead of where I would be if I was in your spot. It's okay if you haven't mastered it yet. We're not done. We're not done it yet. It's coming. You'll get it by the end. Okay. Hopefully you're all starting to get it now, but it's okay if you don't feel overly confident on it at this point. Here's your homework. Let's finish up the practice questions on page 52. You got to start on them right now for the next 2 or 3 minutes. See what you can do, and then say finish them up for homework tonight, please.